Again, welcome back to Inferential Statistics in Decision Making. These lectures cover the confidence interval for the mean. We start with the large samples. So our main objective is to learn how to find a point estimate and also a margin of error. We're also going to learn how to construct and interpret the confidence interval for the population mean. We're also going to determine the minimum sample size required when estimate the mean, the population mean. So a point estimate is a single value estimate for a population parameter. And most unbiased point estimate of the population mean is the sample mean. As we said previously again, the population parameters are always fixed, but the sample parameters may change. They are variable, they vary. So we may take two samples from the same population. The mean of both samples may be different, but again, population mean is always a constant value. So to estimate the population parameter, here we are talking about the mean is the mu, and also estimate sample statics, which is the S bar. As we said, the sample statics values normally vary, but the population parameters values are always constant. So we have an example here to find the point estimate for population mean. Here we say market researchers use the number of sentences per advertisement as a measure of readability for magazine advertisement. The following represent a random sample of the number of sentences found in 50 advertisements. Find a point estimate of the population mean. And this came from the Journal of Advertising Research. So these are our values from 9 to 20. And again, the total is 50 advertisements. So the next thing we should do, or what we need to do, is to find a sample mean of the data, which will be the total values divided by the sample size. Again, the question said that the sample size is 50, and we have each value for each sample. So we have to add all the values here, all the 50 values, then we divide by 50, and that gives us 12.4. So this means our point estimate for the mean length of all the magazine advertisements is 12.4 sentences. Now, each sample value represents the set number of sentences, because the question said the following represent a random sample of the number of sentences found in 50 advertisements. So each, again, the number of sentences for each 50. So we had all the sentences, then we divide by 50, and that gives us 12.4. So our point of estimate will be 12.4 sentences. Next, we can have what we call the interval estimate. So as we said, the point estimate is one specific value, the mean, one value. But an interval always use the term also range of values. So it will be more than 1 point. It's used to estimate the population parameters. So again, our point estimate was 12.4. So if we are using this scale from 9 to 16, we saw our interval estimate will be somewhere, let's say 10.5 to 14.5. But the point estimate is the middle, which is 12.4. So interval estimate is we have to find the interval from 10.5 to 14.5, where we have the red parentheses. That will be our interval. So here we say the interval again, or the range of values, is normally used to estimate the population parameter. Now, how confident do we want to be that the interval estimate contains the population mean? So this is where we will start with the confidence interval concept. So here, the interval again from 10.5 to 14.5. How confident we are that the actual mean, or we say the point estimate, will be between that interval. It will be inside the interval. So that leads us to the level of confidence. So a level of confidence, that is the probability that the interval that we estimate or the interval that we have contains the population parameters. So it can be 95%, 90%, or 0.9. If we are using values, we may use the probability that the interval estimate contains the population parameter. Maybe it's 0.90 or 90%. So this example give you, we have a normal distribution or our bell curve. The center, our Z is 0. To the left, we have negative ZC to positive ZC. This will be our critical values, the shaded area. So here we say C is the area under the standard normal curve between the critical values. Now, the remaining area in the tails will be 1 minus C, because we know in probability the total value is 1. So if we know the critical values area, so the whole remaining area will be 1 minus C. The value is C. So that's what, so the left side will be half of 1 minus C. To the right side will be also half 1 minus C. C will be the blue area. So in this case, we can use the standard normal table to find the corresponding z-scores. This is what we did in our previous example or the previous lectures, where we find again the z. From the z value, we were able to find the probability using the standard normal table. So if the level of confidence is 0.90 or 90%, this means that we are 90% confident that the interval contains the population mean. Now, this will be the whole concept. So the C area will be 90% or 0.90. So this means the remaining area 1 minus C will be 0.10. So to the right, it will be 0.05. To the left, it will be 0.05. Because the total area should be 1. Probability, total probability, or sum of all probabilities is always 1. So we have here, if we, again, we are assuming the level of confidence is 90%, then the remaining will be 0.10 or 10%. So this means to the right and to the left will be 5% each, which is 0.05. Now, if we look at our table, we can see that the corresponding value here for the z-score will be negative 1.645. To the right also will be 1.645. And there's a formula that we can use to find the z. Again, we're going to discuss that in the future. So the corresponding z value are plus or minus 1.645. If I know the p, I can find the z from the standard normal table. Or if I know the z, I can also find the p in the standard normal table. So next we talk about sampling error. A sampling error will be the difference between the point estimate and also the actual population parameter value. So here we use the term point estimate. Estimate means it's not the actual value. So this is not the actual value. So if the sampling error is 0, that means the point estimate value and the actual parameter value are the same. And that's always our main goal. So we say here for population mean, the mu, the sampling error now will be the difference between the sample mean minus the population mean. So the difference between the sample mean and population mean is called the sampling error. So now, if the sampling error represents 0, then it means the sample mean and the population mean are the same. So mu is the generally unknown. The population mean is always unknown. But S bar, or the sample mean, may vary from a sample to sample. So when we collect our sample, even we can collect 2 samples, the size are the same. But since the values may change, at least there may be a slight difference between the mean of the two samples. So that will lead us to the concept of margin of error. So a margin of error is the greatest possible distance between the point estimate and also the value of the parameter it is estimating for a given level of confidence, which we call the C. So again, the greatest possible distance between the point estimate and also the value of the parameter it is estimating for a given level of confidence, which is C. So this means to find the margin of error, we normally denote E, uppercase E, as the margin of error. It will be, again, the Z at the critical area times the standard deviation of the sample. Now, the standard deviation of a sample is always the standard deviation of the population divided by square root of the sample size. So we are going to have the C value times standard deviation of the population divided by square root of the sample size. Sometimes this is called the maximum error of estimate or the error tolerance. In our cost textbook, we use the term the margin of error. So let's see this example. Find the margin of error. Here they say we should use the magazine advertisement data that we used previously. Here we have 50 sample size of different number of sentences for each advertisement. There's advertisement at 50. Now they say we should use the magazine advertisement data, and also we should use 95% confidence level to find the margin of error for the mean number of sentences in all the magazine advertisement. So we know that here they gave us the standard deviation to be 5, assuming the standard deviation is about 5.0. We already know the mean. We calculated the mean before. That's the main thing we did the previous. We had all the sample values for each sentences. Then we divide by 50, which is again the size of the sample. So here we have the negative ZC and positive ZC, and the middle always Z equal to 0. Now the question says 95%. So which means our shaded area now will be 0.95. Now to the tail, the left and right tail is left with only 5%, which is again 0.05. So if you divide 0.05 by 2, you get 0.025 and also 0.025. So those are our two main. So with these values now, we can find a Z. Normally when the confidence interval is 95%, then we know the Z will be 1.96. So here we have 1.96, to the left negative 1.96. So now we say since 95% of the area under the standard normal curve falls within 1.96 standard deviation of the mean, you can approximate the distribution of the sample means with a normal curve by the central limit theorem. Why? Because the sample size is greater than or equal to 30. This condition is true. So that's why we say this question is about large sample. In our next section, we're going to talk about when the sample size is very small. So if that is the case, we find our E. We said our E, which is the margin of error, is equal to the ZC, which is the critical area, times the standard deviation of the population divided by square root of the sample size. Now, standard deviation of the population was given to us, which was 5.0. Is it? So it's somewhere. One more. Okay, so the standard deviation is given to us to be 5.0 from the question. So we just plug in. So here we know 95% of the area under the standard normal curve falls within 1.96 standard deviation of the mean. So you can approximate the distribution of the sample size with a normal curve by the central limit theory. Again, because the sample size is greater than or equal to 30. So these steps we are going to do is when our sample size is large, at least equal or greater than 30. So as we said, we find the E first, which will be the ZC times standard deviation divided by square root of the sample size. And if, again, our confidence in the interval is 95%, then the Z value will be 1.96. So that's why we have 1.96. We can use the standard normal table to find it. Now the standard deviation is given to us, and of course the sample size is also given square root of 50. So if we solve this problem, our error will be 1.4, or the margin of error will be 1.4. Now you are 95% confident that the margin of error for the population mean is about 1.4 sentences. So the value here represents the number of sentences. Now, next is the confidence interval for the population mean. Here we say when a say confidence interval for the population mean mu. If I want to find the say confidence interval, here you can see that we are going to subtract the margin of error value from the sample size, or I would say the sample mean, sorry, the X by sample mean, and it should be greater than sample mean minus error of margin, or it should be less than the sample mean plus the error E. So that will be our, again, confidence. So how do we find the E? As we said earlier, it will be ZC times the population standard deviation divided by square root of the sample size. So here we say the probability that the confidence interval contains the mu, which is the population mean, is C, the C area. So in words and also in symbols, how do we construct the confidence interval for mean? So first we need to check, in this case, we want to find a confidence interval for population mean if the sample size is greater than or equal to 30. So we are dealing with large sample. So first we find the sample statistics, which is the N and X bar. Normally the N always is given. So that will be the sample mean. X bar is the total X divided by the sample size. Then next we are going to specify the standard deviation for the population if we know it. Otherwise, if N is greater than or equal to 30, then we can find a sample standard deviation S and use it as an estimate for the population standard deviation. But in our question here, the population standard deviation was given to us. So we don't need to find it again, the sample standard deviation. Then the third step, we can find the critical value for the ZC that correspond to the given level of confidence. Here we can use the standard normal table as we did in the previous lectures. Then if we know that, we can find the margin of error now, because now we know the ZC, we know the population standard deviation divided by square root of the sample size. Then we're going to find the left and also the right endpoint to form the confidence interval. So to the left will be S bar minus E, to the right will be S bar plus E. So this means our population mean will be between the interval of X bar minus E to S bar plus E. Again, S bar represents the sample mean. So let's solve this problem. Here they say we should construct a 95% confidence interval for the mean number of sentences in all magazine advertisements. So the solution here is that we can recall we add all the sentences for all the 50 sample. We divide by 50 and we get 12.4. So here we know the X bar will be 12.4. Also, we're able to find the E, which is 1.4. So if that is the case, then I can find my left endpoint and right endpoint. So the left endpoint will be 12.4 minus the 1.4, and the right endpoint will be 12.4 plus 1.4. And that gives us the interval between 11.0 to 13.8. So that will be the answer. The interval for the population mean is greater than 11.0, but less than 13.8. This is with 95% confidence interval. So let's see the next example here. They say a college admission director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years, and the population normally distributed. We should construct a 90% confidence interval of the population mean age. So here we have all our necessary Z values. So the mean Z0 to the positive critical area to the negative left side critical area. Since again, the blue shaded area is 90% or 0.9, then to the left and right will be 0.05 or 5%. So that's what we have here. Half 1 minus C is 0.05. So, and also we know the negative ZC and positive ZC, because ZC is equal to 1.645. So if that's the case, we can find the E. We know the ZC. Standard deviation is known. We know the sample size. So we get 1.645 times 1.5 divided by square root of 20. And that will give us again 0.6. So 0.6 will be our E. Now, if we know the E, we're almost done. So the confidence interval, the left endpoint, the right endpoint. The left endpoint will be 0.6 from the leftmost value. To the right, it will be 0.6 plus. In this case, we are talking about the mean. So X bar minus E, 22.3, so that will be from the leftmost. And then X bar plus E is 23.5. So this means our interval here will be 22.3 to 23.5. So that will be our, again, values here between 22.3 to 23.5. And the diagram shows here. So with 90% confidence, you can say that the mean age of all students is between, again, 22.3 and 23.5 years. Now, next we are going to learn how to interpret the result. We said that the mu is always a phase number because the mu is the population parameter. All the population parameter, including population standard deviation, is always fixed number. So it is either in the confidence interval or not. So again, incorrect way of interpreting, we say there is 90% probability that the actual mean is in the interval of 22.3 to 23.5. Now, what's the correct way? We say that if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of this interval will contain the mean, the population mean. So again, the horizontal segment will represent a 90% confidence interval for different samples of the same size. Then in the long run, we have 9 of every 10 searching interval will contain the mu, which is the population mean. Next is the sample size. Now, sometimes when we are doing an experiment or research, we have to consider the sample size. Now, we can see that this sample size formula came from the margin of error formula, because we can see n equal to CC, population standard deviation divided by the E, which was what, again, we were looking for. E is the margin of error. Here, the reason why we square, because the E, the margin of error, remember, the formula will give us ZC times standard deviation of the population divided by square root of n. So when we looking for n, if we have square root of n, when you cross the equal sign, it's going to square everything. So that's why n equal to ZC times standard deviation divided by the margin of error, all square. So if the standard deviation, again, this standard deviation is the population standard deviation, is unknown, then we can estimate it using S, again, provided we have a preliminary sample with at least 30 members. So let's see example here. Here they say you want to estimate the mean number of sentences in a magazine advertisement. How many magazine advertisements must be included in the sample if you want to be 90% confident that the sample mean is within 1 sentence of a population mean? Here they say we should assume that the standard, again, deviation for the sample is 5.0. So we came up with a normal distribution curve. We know it's 0.95 because 95%, which means to the left and right non-shaded area will be 0.025. So this means we have minus Z to positive C, minus ZC to positive CC. So since it's 95%, then ZC will give us 1.96. Again, we can find that from the standard normal table. So we know that ZC is 1.96. We know that the standard deviation was given to us 5.0. And also we know E equal to 1. So with these 3 values, we can be able to find a sample. Again, this is the question. Assuming that the sample standard deviation is given. What's the question? Same sample, confident that the sample means within 1. So you want to estimate the mean number of sentences. So this is our question, the mean number of sentences in magazine. So we plug in the values, 1.96 times 5.0 divided by 1, because E is 1, all square, so we get 96.05. Now here we say when necessary, we should run up to obtain the whole number. So for example, 96.001, we make it 97. So in summary, in these lectures, again, we learn how to find a point estimate and also the margin of error. We also learn how to construct and also interpret the confidence interval for population mean. Here we are using the large sample concept. So we determine the minimum sample size required when estimate the population mean. Again, wish everybody the best and thank you. See you in the next lectures.